Good morning. This is lecture of physics for mechanical 2. We are dealing with unit 4 and the name of the unit is electromagnetic wave. Our today's topic is related to our previous lecture video, that is the propagation characteristics for conducting and dielectric medium. In our previous lecture video we have done some important formulas, like the formulas for the current density in the lossless medium. In the lossless medium, phase constant, velocity of propagation, wavelength and intrinsic impedance formula we have revised. And in the lossy medium, attenuation constant, phase shift constant, phase velocity and the wavelength we have done. And we have done materials in electromagnetics, that is conductor and dielectric. And then after that we have find some criteria for the good conductors and dielectrics, means how can we know the medium is conducting or not. So criteria for the good conductor is sigma upon omega epsilon is greater than 1. And the criteria for the good dielectric is sigma upon epsilon is less than 1, because the surface current charge density is not available on the good conductor. And the criteria for the quasi-conductor is sigma upon omega epsilon is equal to 1. Quasi-conductors are those which are not good conductor and not insulator also. Then in the wave propagation characteristics in good dielectric, here we find out alpha, that is attenuation constant, which is equal to, for the good dielectric, is sigma upon 2 under root of mu upon epsilon. And the phase shift constant, that is beta, for the good dielectric is, after applying binomial theorem, omega square root of mu epsilon into 1 plus sigma square upon 8 omega square epsilon square, this. Next is velocity, which is equal to square root of mu epsilon into 1 minus sigma square upon 8 omega square epsilon square. And after that we are going today the characteristics for the good conductor. Good conductor is those in that the J is not equal to 0 and rho is not equal to 0. मतलब surface current, charge current density and the current density and the charge density is not equal to 0. In the wave propagation characteristics in the good conductor, we have gamma. Gamma is equal to propagation constant, which is a function of two parameters, attenuation constant and phase shift constant. Now gamma is equal to square root of eta omega mu sigma minus omega square mu epsilon. Now taken out eta omega mu sigma as common, we get 1 minus omega square mu epsilon upon eta omega mu sigma. Now omega cancel out with omega and mu cancel out with mu. So we are left only with eta omega mu sigma minus 1 omega epsilon upon eta sigma. We are here we are doing rationalization with eta. So multiplied and divided by eta into eta. So here become eta square and here is eta. As we know, eta square is equal to minus 1. So gamma is equal to eta omega mu sigma into 1 plus eta omega epsilon upon sigma. Now the criteria for the good conductor is sigma upon omega epsilon is greater than 1. And the reciprocal of this is less than 1. So we are able to apply binomial theorem here. So after applying binomial theorem here, this factor eta omega epsilon upon sigma is 0. This can be neglected. Thus gamma is equal to eta omega mu sigma into 1 plus 0. So we are left only with gamma is equal to eta omega mu sigma square root. Now multiplied and divided this factor by 2. So square root 2 eta omega mu sigma upon 2. So this is the procedure. How can we reduce from this to this gamma? First of all, gamma is equal to eta omega mu sigma minus omega square mu epsilon square root. After taking eta omega mu sigma as a common, we are left only this factor. Then we have done rationalization here and we get this factor. Now applying the criteria for the good conductor, which is equal to sigma upon omega epsilon, which is greater than 1, or omega epsilon over sigma is less than 1. So we can neglect this factor. After neglecting this factor, we are left only with gamma is equal to eta omega mu sigma square root. So gamma is equal to, after multiplying and divided by 2, 2 iota omega mu sigma upon 2 square root. So gamma, now adding 1 and minus add and subtract 1 in this factor. So after adding and 1 subtracting 1, we have gamma is equal to 1 plus 2 iota minus 1 omega mu sigma upon 2 square root. Now 1 plus 2 iota minus 1 is equal to 1 plus iota whole square, because when we are applying identity here, the identity is a square plus b square plus 2ab. Here a is 1, that is 1 square, b is iota, that is iota square, and 2ab, 2 iota, iota square is equal to 1. So this factor can be written as 1 plus iota whole square. So gamma is equal to 1 plus iota whole square omega mu sigma upon 2. After taking out 1 plus iota whole square from the square root, we get square root of omega mu sigma upon 2. Now multiply this factor inside the bracket. So gamma is equal to under root of omega mu sigma upon 2 plus iota omega mu sigma upon 2. See, these two factors are approximately same. As gamma is a complex quantity, we know gamma is equal to alpha plus iota beta. Alpha is an attenuation constant and beta is a phase shift constant. So after comparing these two quantities, this will become alpha plus iota beta is equal to under root of omega mu sigma upon 2 plus iota omega mu sigma upon 2 square root. So equating real and imaginary part, alpha is equal to omega mu sigma upon 2 decibel per unit meter, and the phase shift is equal to square root of mu sigma mu omega upon 2 square root rad per meter. Look, these two values are same for the good conductor. So in this, first of all, we have added and subtracted 1 in this factor, and this value is equal to 1 plus iota square. After filling the value of this, taken out 1 plus iota as a common, it will become omega mu sigma upon 2 square root. Now multiply this factor inside the bracket, we will get this. Now the standard value for the gamma is alpha plus iota beta. Alpha is an attenuation constant and beta is phase shift constant. So alpha will become this, omega mu sigma upon 2 square root, and beta is equal to omega mu sigma upon 2. This is attenuation constant and this is phase shift constant. Next is velocity of propagation, that is Vp, which is equal to omega upon beta. As we know, the value of beta is omega mu sigma upon 2. So fill this value in the place of beta. We are left only with Vp is equal to 2 omega mu sigma square root. And these formulas are very important for the numerator. Now the next topic is depth of penetration. As we know, we are dealing with conductor, that is good conductor, and in good conductor wave is attenuated with the passage of time. Now the depth of penetration is when the wave is moving in the conductor, the amplitude of the wave is attenuated by 1 upon E of its actual amplitude, time of its actual amplitude. So that depth or that distance through which the wave starts attenuating from its original amplitude is known as depth of penetration. So the depth of penetration is defined as that depth at which the wave attenuates to 1 upon E, or approximately 37% of its original amplitude, is known as depth of penetration. So the simple definition of depth of penetration is that depth through which the wave gets attenuated by 1 upon E time of its 37% of its original amplitude. It is denoted by the symbol delta. Its unit is meter because it's a type of distance. Depth of penetration is also called skin depth because it is measure of the depth to the width and to which an electromagnetic wave penetrates the medium. So depth of penetrate is that depth, that distance in which the wave penetrates the medium and gets start reducing its amplitude. That is known as depth of penetration, and it is represented by delta. Now its derivation. Let us consider a wave which is propagating along positive z direction. Then attenuation of the wave is equal to E is equal to E naught e raised to power minus alpha z. As we have discussed, alpha is an attenuation constant. So attenuation electromagnetic wave is defined by this factor, where E naught is amplitude of the wave at the surface of conducting medium and alpha is attenuation constant. Now at z is equal to delta, because according to the definition, depth delta, z is equal to delta means wave is propagating along through this distance. So E is equal to E naught e raised to power minus alpha delta. This is equation number 1. From the definition is that the depth of penetration is that depth through which the wave is attenuated by 1 upon E of its original amplitude. So E is equal to E naught e raised to power minus 1, or is E naught upon E. This is equation number 2. Compare equation number 1 and 2. E naught e raised to power minus alpha delta is equal to E naught upon E. E naught cancel with E naught, so e raised to power minus alpha delta is equal to e raised to power minus 1. Now exponentials will cancel out with each other and alpha delta is equal to 1 and delta is equal to 1 upon alpha. Here delta is an skin depth or the depth of penetration. So this is very easy. First of all, we have to write the electric field in the form of attenuation constant. Here E naught is the actual amplitude and z is equal to delta here, because we are dealing with the skin depth. So E is equal to E naught e raised to power minus alpha delta. Now according to the definition of the skin depth, E is equal to E naught e raised to power minus 1. So after comparing 1 and 2, E naught e raised to power minus alpha delta is equal to E naught 1. So after solving this, delta is equal to 1 upon alpha. So in this lecture, we have derived some wave propagation characteristics for the good conductor, that is alpha, that is attenuation constant, and beta. And after that, velocity. And after that, we have doing very important topic, that is skin depth or depth of penetration. And the depth, the formulas are, first of all, alpha is equal to square root of omega mu sigma upon 2 square root, and the unit of the alpha is decibel per meter. And the formula for the beta is omega mu sigma upon 2 square root, and the unit of the beta is rad per meter. Next is velocity. Formula for the velocity is square root of 2 omega upon mu sigma. As you all know, the unit of velocity is meter per second. Next is skin depth, which is equal to delta is equal to 1 upon alpha. Here the value of alpha is equal to, from this is value of alpha is omega mu sigma upon 2 square root. So after filling value of alpha, delta is equal to 2 square root of 2 mu sigma omega sigma. So this is some important formulas for the good conductor after applying the criteria. Now here are some numerical problem. The first numerical is find the skin depth, that is delta, at a frequency of 1.6 megahertz in aluminium, where sigma is equal to 38.2 meter second per meter and mu r is equal to 1. Also find the propagation constant and wave velocity. What we have to find? We have to find skin depth, propagation constant, that is gamma, and wave velocity. And given is frequency, that is f 1.6 10 raised to power minus 6 hertz, mu r relative permeability, and sigma surface charge density. First of all, the formula of delta means skin depth is 2 upon omega mu sigma square root. As we know, omega is an angular frequency and here we have given simple frequency. So omega is equal to 2 pi f. After filling the value of omega, 2 cancel with 2. Delta is equal to 1 upon pi f mu sigma square root. After filling the value of f and sigma, f is equal to 1.6 10 raised to power 6 hertz and sigma is equal to 38.2. So after filling these values, mu, and similarly we have given mu r. not mu. Mu r is relative permeability, which is equal to mu upon mu naught. So from here, mu is equal to mu naught into mu r. The value of mu naught is 4 pi into 10 raised to power minus 7. It is a standard value, and mu r is equal to 1. So simply mu is equal to this. So fill all the parameters in the formula. Delta is equal to 1 upon pi 1.6 into 10 raised to power 6 into 4 pi into 10 raised to power minus 7 into 38.2 into 10 raised to power 6 square root. After solving this, delta is equal to 6.44 into 10 raised to power minus 5 meter. Next is alpha. Because in the numerical problem we have to solve wave propagation, and the wave propagation is a function of attenuation constant and phase shift constant. So alpha and beta, as we have derived formula, same, which is equal to 1 upon delta. So alpha is equal to 1 upon 6.44 and 10 raised to power minus 5. After solving this, alpha is equal to 15.62 into 10 raised to power 3, and beta is also 15.62 into 10 raised to power 3. And the propagation constant gamma is equal to alpha plus iota beta. After filling the value of alpha and beta, we get propagation constant. Next, we have to find velocity. Velocity is equal to omega upon beta. So omega is 2 pi f and delta is this. So we have all the values. Substitute here, we get velocity. So this such type of numerical can be are very important for the examination point of view, and these are some formula which we have derived today, and they are very important. So thank you.